So I think to make this problem a little bit more realistic compared to what we did with this year is we're going to put a squared behind here. And my job is now to get this x by itself. So I'm going to rewrite it over here. And the first thing I'm going to do is start to isolate x because x wants its own room. So no one's going to move into the problem and get comfortable. Everyone's getting out of there. So the first thing I move is any addition, subtraction. So I'm going to start by adding 7. And that gives me 18. The next thing we're going to do is move anything that's being multiplied or divided. And this 3 is multiplying to the parentheses, so I'm going to move it by dividing. And that turns my 18 into a 6. And then the next thing I'm going to get rid of is the exponent, so I'm going to square root. So when I square root this side, that cancels out the 2, so that you're just left with, I'm going to move over here now, x plus 2. And then you're going to square root the 6, and you could just write it like this. Remember, when you square root, you get 2 answers, a positive version and a negative version. And now to get x by itself, we actually have 2 problems. We have x plus 2 with the positive version of the square root of 6, and x plus 2 with the negative version of it. And the square root of 6 is like 2 point something. I'm just going to leave it as the square root of 6 now. I don't have a calculator in front of me. So either way, to get x by itself, I'm going to subtract 2. And here's one problem. And then here when I subtract 2, the other answer is the negative version of this, subtracting 2. So again, this is 2 point something, so you take that 2 point something, subtract 2, you're left with a decimal. I'm not quite sure what it is, maybe it's like 0.3 or 0.4. And then here this is a negative 2 point something, and when you take away 2 more, you'd like negative 4 point. I'm not quite sure again what exactly it is. So one type of x, we isolate x, we work backwards in the order of operations. So when we get into problems like this where we have more than one type of x, okay, say more than one type, we've got an x cubed, an x squared, an x, is we're going to factor it. So the key thing is we're going to factor, and we learned all these different ways to factor in chapter 3 and 4. You need to make sure it's in standard form, so it's got to go from highest power to lowest power, and it has to equal 0. And once we're done factoring it, we need to set our parentheses equal to 0 and solve from there. So the first thing I'm going to do is just add this 48 over. So it is now going to be in standard form. And since there's 4 terms, what we learned is that we group them up. Some of you do the box. You could put this in the top row of your box and the bottom row of your box. So what can I factor out of both of these? I can factor out an x squared. Whoops, squared. And then x squared times what gives me x cubed, that's x. And x squared times what gives me this negative 12x squared, that's negative 12. So then I have identical parentheses, I should have another x plus negative 12. And what did I factor out? What times x gives me negative 4x, and that's a negative 4. So from there, we get our 2 sets of parentheses. And as it turns out, this one can factor more. This is a difference of squares. This popped up on that factoring mile marker. It can turn into x plus 2 and x minus 2. And now that I've factored it completely, I can ask myself what makes my parentheses equal 0. I get negative 2, 2, and 12. So those are my solutions. Negative 2, 2, and 12. Then as the year progressed, we had something like this. So again, you can kind of think of this as there's one type of x. The main thing is we still want to isolate the x. So we will have to get rid of the square root. So it's kind of like that exponent step. How do you undo a square root? Because that's like a 1/2 power. So there's still one type of x. I'm going to isolate it. And so that means, if I rewrite it over here, so I will isolate x. He still wants his own room, as I tell my freshmen, and I'm still basically just working backwards in the order of operations. So the first thing I'm going to move is the 6. I'm going to add it over. And that gives me 7. And now to get inside the square root, I'm going to square both sides. So the square cancels out the square root, so you're just left with 10x plus 9. And then when I square the 7, I get 49. And now I'm just back to getting x its own room. Subtract 10, or I'm sorry, subtract 9. Divide by 10, and your answer is 4. And this is where we started talking about extraneous solutions, because in the original problem we have a square root, and we can't take a square root of all numbers. We can only take the square root of positive numbers. So you just want to make sure that that would work. If you put 4 back in here, 10 times 4 is 40. 40 plus 9 is 49. The square root of 49 is 7. And then that 7 taking away 6 is 1. So this is not an extraneous solution. And then the most recent type of problem, here x takes on a whole different look. It's now an exponent. So again, the idea is we still want to get, x by itself. We want to isolate it, but this time we're going to isolate the base and the exponent because they're kind of stuck together. So what we did is we just added 7. Then we divided by 3. And then once it was just the base and the exponent, and it's an exponent problem, we turned it into a log. Oops. So you would do log e, which is just ln. 7 equals x. And then you can go to your calculator and type in ln 7, and you get x to be 1.946. Okay? So that's what we've done so far in solving. In this section, what's going to happen is x is going to be in the numerator, it's going to be in the denominator. We don't like fractions, so mainly what we're going to do is work to get rid of the fractions. So there's different types of problems. There's just, when you have one rational expression equaling another one, and the easiest way to deal with this one is to use cross multiplying or cross products. So again, it's used when one fraction equals another fraction. Before we start, we've been working on this, identifying the domain and the excluded values. So, looking at your domain, remember the denominator can never be 0. So I would never pick 3. So just looking at the domain, x can't be 3. This one, a little tougher to see. Maybe you want to set it equal to 0, because this is not a difference of squares. This doesn't have a perfect square root. So I can add 27, and then the square root of 27. And it'd be a positive and negative version, sorry you can't see that. 27 I could break down to the square root of 9 and the square root of 3. This is the better answer. And so adding to that list, I would never, as far as my domain works, whoops, this is supposed to be a square root. In addition to 3, I would never also not pick the positive version of 3 square root of 3 or the negative version. So these are my domain or my excluded values. All right. Now, we're ready to go into cross products. Cross products just means you go crisscross and you multiply. Okay? Because if these fractions are really equal to each other, so for instance, we know that 1/2 is equal to 5/10, right? Then when I crisscross and multiply, 1 times 10 is 10, and 2 times 5, I should get the same answer when I crisscross and multiply. So first I'm going to take -1 times x squared minus 27, and then I'm going to take x minus 3 times x minus 4, wrap them in parentheses, and then it's just different math on both sides. Here I'll distribute the -1 in. Here I would start distributing, so I'd get x squared minus 4x, and then this would distribute, I would get -3x plus 12. I'm starting to notice they have more than one type of x. So what I'm going to have to do is factor it, but first let me clean up this side. And now it's easier to factor when this is positive. So I'm going to bring this and add it to this, so I get 2x squared. And then I'm going to take the 27 and subtract it to the 12. So that I now have plus -15. Now, if you don't like to factor this, this is now equaling 0, you could do the quadratic formula here, but we've been factoring so much we're going to keep up with it. So I'm going to get -30 x squared and -7x, and then I find the factors are -10x and 3x. And then I rewrite it, but instead of this version of negative 7x, I want this version of negative 7x. So just going to rewrite it. And now that it's in 4 terms, or maybe you put this in a box, top row of the box, bottom row of the box, I can factor a 2 and an x out of both of these. And then 2x times what gives me that? That's x. 2x times what gives me this? That's negative 5. And then this will also be x plus negative 5. So what times x gave me 3x? That's just a 3. And then 3 times the negative 5 gives me the negative 15. So now I have 2x plus 3 and x plus negative 5. And again, we've been factoring just what makes them 0. This is an easy one. X equals 5. This one isn't as easy to see, so if you want to set it equal to 0, then I would subtract 3, and x would be negative 3/2. So these are some of my solutions. So now that they are my solutions, I want to see were any of those in my excluded values or domain restrictions. Because if I can't use them in the original problem, they definitely can't be my answer. And as it turns out, no. So this is my answer, negative 1.5 and 5. And then this is my domain restriction. Okay? All right, let's take a look at the next one. Okay, so in this problem, again, one fraction's equaling another. I'm just going to multiply. So 4 times x plus 6, and then 5 times x. And here they're just the same type of x. I'm just going to distribute. This one's much easier than the other one. Same type of x, so I can just isolate x. So I'm going to subtract the 4x over. And then that's my answer. Now, what I forgot to do is identify my domain and excluded values. In this denominator, I would never pick 0. And in this denominator, I would pick negative 6. So now I just need to see, do any of these turn out to be my excluded values? Because if they are, then this would be considered what we call that extraneous solution. But they're not. Here's my answer. Here's my domain restrictions, or my excluded values, and that's how you solve with cross multiplying. Again, it only works if you have one fraction equaling another fraction. So now what we're going to look at is, what if you don't have that situation? Okay? And since you have so many fractions, in the end our goal is going to be, let's just get rid of the fractions. Let's get rid of those denominators so we don't have a fraction. Okay, so I had to pause the video, so I'm not quite sure if I'm going to repeat anything of what I just said. So, how do we start solving if we have more than one fraction? Well, again, what I want you to do is start by adding the opposite. And when I say adding the opposite, I'm looking at this between fractions. So for instance, this minus 6 here in between the fractions, I want you to add the opposite and apply it to the numerator only. If you want to factor the denominators, or I'm sorry, add the opposite in the denominators, you can, but you don't need to on this section. So that's what A means. So first, let's factor all the denominators completely. So always start with the greatest common factor. I can take an x out, and I'm left with x minus 3. This is just left with x minus 3, can't factor it, and this is just x. Let's figure out this domain, step C, and your excluded values. So I could never pick 0, 3, 3, and 0. So I don't need to write them all just once. So 0 and 3, can never pick those. Next thing we're going to do is we're going to find the least common denominator. We did that with adding, subtracting. Some of you can just look here and see the least common denominator. If you can't, then I recommend you make that least common denominator table. So the least common denominator table would look like this. So fraction 1 would have factors of x and x minus 3. Fraction 2, I'm writing this a little too close to this, would just be x minus 3. It repeats, and fraction 3 would have an x, so if I bring everything down, remember that's your least common denominator, x and x minus 3. So x minus 3, the terms are going to get wrapped in parentheses. So now that we have our least common denominator, this is the difference between adding and subtracting. Normally we would just multiply by the term we need to make the least common denominator. Now what we're going to do is multiply the numerator, the entire numerator in each term, by the entire least common denominator. So this entire least common denominator is the change. So first, I'm going to go to these. I don't need the unfactored versions anymore. Okay, sorry, I had to pause it. So again, I'm not quite sure what I said. I might be repeating. So what I was mentioning last is I don't need these versions. I want the factored versions. So what I'm going to do is take each fraction and multiply it by its entire least common denominator. Okay, so I'm going to use these sticky notes. So the first thing I'm going to do is just look at the first one. Okay, and I want to multiply this fraction by x and x minus 3. So here is multiplied by x and x minus 3. And then I'm going to do the same to the next fraction. I'm going to multiply this one by x and x minus 3. And then I'm going to multiply this one by x. It's really squished in there, and x minus 3. Sorry, like I said, that definitely went, I was not putting that in a good spot. So let's take a look at the first fraction. The idea is you're going to cancel out the common factors for each term or fraction, and as you do this, your denominator is just going to disappear, and then we won't have a fraction anymore. We won't have a denominator. So what I'm saying is start with the denominator. This x minus 3 will take out that x minus 3, because in the top now we have 18x and x minus 3. And the fact that I'm changing all the fractions works. This allows me to do this. And then this x is going to take out this x, so that the only thing I'm left with in this whole fraction now is 18. Okay? And again, since I'm multiplying everything by the same thing, this is keeping this balance, that equal sign staying the same. All right, let's go to the next one. So let me get my sticky notes. So now I'm going to take this fraction. I'm going to start with the denominator. This x minus 3 is going to take out this x minus 3. And when I'm done, I have a plus here. You can't see it. And a negative 6 times an x. So that's negative 6x. When I'm done. Denominator's gone. And then when I go to my last fraction, and I start with the denominator, this x will take out this x, so I'm left with the factors of 5 and x minus 3. And now we're back to very simple solving. They're the same type of x. I'm just going to first distribute that 5 in. And now to get x by itself, I'm going to add 6 over here, the 6x. I'm going to add the 15 to over here. Whoops, I added it, but I didn't change it. Sorry, it's 11. And now to get x by itself, I'm just going to divide by 11. And when I'm done, I get x equals 3 as my answer. So one thing I want to check is my answer one of the domain restrictions or excluded values? And as it turns out, I can't have 3. So this is what we call an extraneous solution. Okay? Even though we solve for it, it actually won't work when we put it back into the original equation. Again, I'm assuming I did all my math right. So, all right, next one. So first thing I'm going to do is add the opposite. I don't need to do that. Then I'm going to factor my denominator completely. I'm not going to go over the factoring. At this point, we should be able to do that, so you can pause the video. But I end up with x plus 3 and x plus negative 2. Lost my parentheses. I'm going to put a denominator, the 1, but we won't factor that. And then I can't factor this. So if you don't see your least common denominator, again, make your table. So I'm going to do that up here. Got fraction 1, fraction 2, fraction 3. Fraction 1, I would put an x plus 3 and x plus negative 2. Fraction 2 has a 1, but 1 doesn't change anything, not in factors. And then in fraction 3, I just have the x minus 2. And so x plus negative 2 is the same thing. So it'll fall in the same category. Bring everything down. And I get an x plus 3 and x plus negative 2. And again, the 1 in factors does not matter. So this is my least common denominator, x plus 3 and x plus negative 2. Now that you found it, here's the difference. We're going to multiply the numerator in each term or fraction by the entire LCD. So we don't need these old ones. So I'm going to multiply, I'm just going to rewrite this one so it's a, I guess, I don't know, I didn't need to do this, but same level. So I'm going to multiply this whole fraction, okay, by the least common denominator. Wrap them in parentheses. I'm going to multiply the next fraction by it. I don't have a lot of room, so I'm going to stack it one on top of the other. And I'm going to multiply my last fraction by it as well. Okay, so now that I've done that, I'm going to go to each fraction and cancel out the denominators. Start with the denominator. This takes out this takes out this, and when you're done, you're just left with negative 13. Okay? Now I'm going to go to my next fraction. So as it turns out, nothing cancels out with 1. So I have the factors 2, x plus negative 2, and x plus 3. And I'm supposed to multiply these. So for now, I'm just going to write them down. 2, and the x plus 2, and the x plus 3. And then in my last fraction, I can't do this. This x minus 2 will take out this. So on the other side of the equal sign, I'm left with x minus 3 and x plus 3. Alright, whoops, not on the other side. There's a plus sign here. Sorry, I wasn't paying attention. So what I have to do is simplify my numerator. So I'm actually going to start with this. I'm going to multiply x minus 3 and x plus 3. So start distributing. X and x's, x squared. Here I get a 3x, and here I get a negative 3x. Those cancel out. And then I get a negative 9. Now I need to take the time and multiply this. If you remember, we got x plus 3 and x plus negative 2, which I forgot here, by factoring this. So if I multiply this, I'm going right back to here. Otherwise, if you don't realize that, x visits and then negative 2 visits or distributes, and when you're done, you're just going to get x squared plus x plus negative 6. And then that still is going to multiply with the 2, so when I'm done, I get 2x squared, 2x, here's negative 12, and then in this other one I got x squared plus negative 9, and then this negative 13's just been on the left side. Definitely have more than one type of x. This is not an easy problem because we will have to factor. I'm going to get everything on one side and combine like terms. So first I'm going to put my x squareds together. The 2x doesn't have anything to combine with. And then negative 12 and negative 9 is negative 21. And when I bring this 13 over to join negative 21, I will end up with a negative 8. So again, this is not an easy problem. I'm going to factor now. If you're really sick of factoring, go to the quadratic formula. So multiply, I get negative 24x squared. And I get 2x on the bottom. So factors of 24, they get me to 2, are 6 and 4, and I'm going to make the 4 negative. So now I rewrite it. 3x squared plus 6x plus negative 4x plus negative 8. Now I'm going to group them. And what can I take out of both of those? I can take out 3x, and I'm left with x plus 2. I need another x plus 2. So what times x gives me the negative 4x? That's a negative 4. And now I've got my factors, x plus 2 and 3x minus 4. And what makes them 0? This one's going to be negative 2. And this one, if you don't see it, set it equal to 0. 3x minus 4 equaling 0. I'm going to add 4. And I'm going to divide by 3, and I get 4/3. Again, this was not an easy problem. What I forgot to do is just talk about the excluded values of my domain. Looking at the factor denominator, I would pick negative 3 or positive 2. So just down here, already here, x can't be negative 3 or positive 2. And I don't have either of those. I have a negative 2. So state your domain restrictions, your excluded values, and then your answer. So that one's done. Again, not an easy problem, but you know, it's just factoring. You got to be good at factoring. All right, last thing. Inverses, they're coming back. So just a reminder that when you find an inverse, that the first thing is you switch x and y, and then the next step is you're going to solve for your new y in its new spot. So get y by itself. So first of all, f of x, that is y. I'm going to quickly switch x and y around. And now with these fractions, you know, this is going to what we just did. I got to get this y by itself. I have one fraction equaling another fraction when I put it over 1. So I'm just going to do cross product. 7 times 1 is 7. And x times y plus 6. And now my goal is just to get the y by itself. So first I'm just going to distribute that in. So now to get this y by itself, work backwards in the order of operations, I'm going to subtract the 6x from 7. They're not like terms, so we can't actually make it 1x. And now to get y by itself, I'm going to move this x. It's multiplied, so I'm going to divide. So when you're done, this is gone, and here is your inverse. 7 minus 6x all over x. And, you know, so again, we're just applying things that we've learned before and stuff that we're currently learning for inverses. And that's it. Those are your notes for 7. What section was this? I don't remember. 7.6, 7.5, 7.5.